Right, guys, we're going to have a look at recapping SOH CAH TOA and applying it to 3D problems, all right, for today's lesson. So just to give your brains a bit of a wake up, if you have a go at the two questions on this first slide, all right, see what you can remember, how to label it, etc., and see if you can find the missing side P and angle Q. And then when you're ready, hit play and we'll go through how to do everything. Okay, right. So we'll come back to these two questions in a second. We'll just have a quick recap so that you can remember how to label a right angled triangle in terms of SOH CAH TOA the correct way. So for any right angled triangle, we can use SOH CAH TOA, but it only works with right angled triangles. So just be mindful of that one. Okay, remember we should know the name of this side. That's a hypotenuse. We've seen that before with Pythagoras. So that's always going to be the longest side and opposite the right angle at that point. Okay, this side over here is the opposite side. It's always going to be opposite to the angle that is marked. So that's not the right angle, it's the other angle that is marked inside our triangle at that point. And hence the remaining side, the angle that is, or the side that is touching the angle, is our adjacent side. So it's the one that is next to. So we do need to make sure that we can label it OA and H appropriately. Right, just a reminder then of the different formulae. So you need to make sure that you know it as sine A, sine X, or sine theta is opposite over hypotenuse. Cos A is adjacent over hypotenuse, and tan A is opposite over adjacent. So you do need to make sure that you know those three formulae. They will never be given to you in an exam, so it's worth having a flashcard with those on, okay, or making them stand out in your book so that you are learning those ones off by heart. All right, and then you can use them to answer the questions. So if we have a look at the first one that you had, your starting points then are to label your three sides. So we know P is our hypotenuse opposite the right angle. The 7 centimeters is touching the angle 46, so that's the adjacent, and then the remaining side is opposite to the angle. If we write out SOH CAH TOA so that we can identify which one of the three formulae we need to use, we know the adjacent is useful because it's labelled 7 centimeters. We know we want to work out the hypotenuse because it's labelled P, and hence the opposite is useless. So anything with an O we can ignore, telling us that we need to use the CAH part of the formula. Okay, so cos is cos theta equals adjacent divided by hypotenuse on that one. If we then fill in our values, so it's cos of 46 is equal to 7 divided by P. Now remember, the proper way of doing this is to rearrange that. So at the moment we don't like the fact that we're dividing by P, so we're going to times both sides by P. That's going to give us P times cos 46 equals 7. Then our aim is to get the P on its own. So we're going to divide both sides by cos of 46, giving us that one, which you can then stick in your calculator and get P equals 10.08 or 10.1 centimeters, depending on how you've rounded. Just remember the trick with this bit. When we've got the cos of 46 equals 7 divided by P, technically all we've done is swap the P and the cos of 46 round, so we get this calculation here. Sometimes you've got to do the swap. Sometimes it could have been P divided by 7, in which case you just times by 7. So you do need to write out your calculation each time and correctly figure out how to rearrange it on that one. Don't cut corners. Right, if we have a look at the second one then, so this time trying to calculate the size of the angle. So again, you need to do it properly and label your three sides. So we know 4.3 is opposite to angle Q. 3.8 is adjacent to angle Q because it's touching the angle, and then the side opposite the right angle is our hypotenuse. We want to write out our SOH CAH TOA and then identify which formula we want to use. So in this case, we know the opposite and we know the adjacent, all right, and the hypotenuse is the useless side, so we don't want anything containing a H, and therefore it's going to be TOA. All right, the formula for that one then is tan theta equals opposite divided by adjacent, or opposite over adjacent. Fill it in. We've got tan Q equals 4.3 divided by 3.8. You can put your 4.3 divided by 3.8 in your calculator, but you don't have to at this point. It's totally optional, but if you do and you end up with a long number on your calculator display, you must not round at this point. But what we do want to do is get rid of the tan. If you remember, when you're trying to get rid of the tan, we don't divide by tan, we use inverse tan. So that's that shift -1 tan button. Okay, so we end up with that. As I say, we can put it in like that without the decimal, or if you've worked out the decimal, use your answer button to help you, and then you should get a final answer of Q equals 49 degrees. there's a quick recap there on finding missing sides and finding missing angles. The work I've asked you to do is just a few questions for each of those as practice, and then you're going to move on to doing it with 3D shapes. So we'll go through one of them. And if you want to pause and give it a go, see what you can work out so far, and then hit play when you're ready for me to go through it. Right, so this is a good one to make sure because we've done SOH before. We started a bit of work earlier on in the year in using it with 3D shapes, but you might want this one in your blue book so that you've got it for reference. So the image below is a cuboid. We are trying to calculate the size of the angle between C and E and EFGH, which is the base of the cuboid. So we're looking at that red triangle there. What we want to do is connect C and E up and then figure out, right, C's at the top, so we want to go vertically down and then find the line that would connect it to make a right angle triangle. So our right angle is down here at G. If we write that out so we can see the triangle a little bit easier, that's the angle we're trying to find at E. Okay, that is between CE and the plane at the bottom. However, we don't know this missing side down here, so we're going to have to do some work to find out EG. All right, we can use Pythagoras to do that. So EG squared is going to be EH squared plus HG squared, so it's 4 squared plus 3 squared, giving us 25. So EG squared is 25. We can then square root that and get 5. So we now know the missing side at the bottom is our 5 centimeters. We can then label our triangle, so we know the 11 centimeters is opposite the angle, our 5 centimeters down the bottom is adjacent to the angle, and E to C is our longest side opposite the right angle and then hypotenuse. We can then write out our SOH TOA and identify which one we need. So opposite we know, adjacent we know, hypotenuse is totally useless, so anything with a H we can ignore, and it's TOA again this time. Our formula then, tan theta equals opposite over adjacent, fill it in. Okay, and remember to get rid of the tan. At this point, we're going to use our inverse tan and then put the 11 divided by 5 in our calculators to give you an answer of 66. Okay, so there are some practice questions for you to have a go at on using Pythagoras and trigonometry in 3D. So it's only SOH TOA and Pythagoras at this point in time. Have a go at the worksheet and remember to post any questions on the help sheet that you might need specific help with. All right, more than willing to help. Good luck.